Hello everyone. This is our video for chapter 13 for our ground school here. This chapter is all about weather charts and briefings. So I thought, let's make this one real, if you will. And I'm going to mostly talk about online resources that you might use if you wanted to go for a flight. Now, before we get into that, just wanted to mention that Rod does talk about things like weather briefings. Yes, you can get a weather briefing over the phone by calling 1-800-WX-BRIEF. It's not something people do a lot today, but it's still an option. Maybe you're out in the middle of nowhere, you don't have access to the internet, you don't have maybe even your smartphone. You're just got nothing. Maybe its battery's dead. I don't know. So a lot of airports, you go to that airport, you'll see that they will actually have a phone that at a minimum you can use to call 1-800-WX-BRIEF. And often you can call maybe the airport manager. If you go to Bloomsburg, there's a little black box outside in the terminal building. And guess what? It allows you to call those people and a couple others as well. Okay. So you can get a briefing on the phone. When you get a brief, there's a couple different kinds of briefings. Rod talks about that. You've got your standard briefing. And if you want to go further in the future, like more than 6 hours in the future, you can use a Outlook briefing. And if you just want to know some stuff, you can ask for an abbreviated briefing. The biggest thing I've ever done with an abbreviated brief is when I was flying skydivers down in Georgia, I would often say, hey, I would like to just get the winds aloft over this airport because I needed it for the skydivers so they could know where they should be getting out of the aircraft. Okay, so if I'm going to go for a flight, even if it's a local flight, my go-to place is right here, Aviation Weather Center. It's aviationweather.gov. Now, if I go to the home, looks kind of like this. And I've got this chart, and I've got a bunch of little dots. The little dots tell me things like, hey, is the weather marginal IFR there? That's what the blue dot means. IFR or low IFR. It'll also tell me about things like SIGMETs and other stuff like that. And we're going to have to talk about what those things are. But one of the most basic weather products out there is a observation. And it's called a METAR, a meteorological report, or METAR. So I can get METARs at different airports, and I can also get forecasts. But if I click on METARs, it's going to show me this nice little graphical tool. I could zoom in a little bit. And I can see things like, here's Wilkes-Barre. And what's it telling me? Now, here's something that's pretty cool. It's got the key over here. So it's telling me exactly what I'm looking at. Now, the winds. Here, this wind is indicating, looks like about 15 knots. I have the big barb and the little barb. If I click on this, it also brings up the text version of this METAR. It'll tell me my temperature, my dew point. Let me go ahead and close that. So my temperature. Wow, that's a really high temperature. And my dew point is 29. What's my visibility? My visibility is 10. That's my altimeter setting. etc., etc. Okay. So this is showing me the graphical version. Let me zoom back out. This is okay, I guess, as far as trying to get a basic idea for the weather, but I prefer to actually see the text version. And this is also something that you're likely to have to know for your knowledge test. So it's not a bad thing to know. So let me go ahead, and you can see I have a couple of these that I like. And I'm also going to say go ahead and include the TAFs, the terminal aerodrome forecasts as well. And here we have it. So I'm going to skip over the TAFs for now, and I'm going to talk about some of these observations. So the first one I have here is for Philly. It says KPHL. This was issued on the 18th at 1754 Zulu. And by the way, it is currently 1758 Zulu on the 18th when I'm recording this. And the winds were 130 at 8 knots. Visibility was 10 miles. They never report if the visibility is over 10. They just say 10. Clouds, it was scattered at 5,000 feet. Scattered at 25,000 feet. Temperature's 19. Dew point is 7. So that's a 12-degree difference. Last week we talked about things like that, and we said if the difference is small, you would expect low clouds. Well, the difference is huge, so we don't expect low clouds, and we don't have them. Altimeter is 30.40 inches of mercury. Remarks A02. So this tells me what kind of equipment they have. The sea level pressure in millibars ends in 292. A more accurate temperature and dew point would be 18.9 and 6.7 degrees. And these other numbers, I'd have to look those up to tell you what those mean. And then we have Lancaster. Now this one is interesting because you don't see this much, but it says COR. That stands for corrected. So they originally reported something else and then they fixed it. One other thing you'll notice that it's usually something 53 is the most common time that these come out. Now, if you're at a towered field and the weather changes significantly, they're going to update the ATIS, and this will also get updated more than every hour, but normally it's once an hour. So the winds there are 150 at 9, 10 miles visibility, few clouds at 5,000 feet, temperature 18, dew point 4, altimeter is 3038. Remarks, same equipment, sea level pressure 288, actual temperature 17.8, dew point is 3.9. Now, if I go a little further here to Binghamton, you'll notice it says auto. So this is an automated system. This is not a weather reporter who generated this. This was generated automatically by a machine. The winds there are 190 at 17, gusting to 27 knots. So anyone care to guess why I'm recording this instead of flying with students on this lovely Sunday afternoon? There's your answer. It's a little windy right now. 10 miles visibility and clear. Not surprising, there's all that wind. Of course it's nice and clear. Right? Temperature there is 12. The dew point there is -4. Altimeter is 30.32 inches of mercury. Remarks A02. They have the same kind of equipment. Peak wind 190 at 27 knots. And that was reported at 1745 Zulu. Sea level pressure is 273. And the actual temperature is 12.2, and the actual dew point is negative. That's what the 1 in this place means. 3.9. Hazleton, weather there, again, automatic. 160 at 10, gusting to 15 knots. Winds varying between 130 and 190. 10 miles visibility, clear. Temperature 13, dew point -1. Altimeter setting 3040. Remarks, same thing. And then if I look at Avoca, it says automatic. Winds are variable at 6, gusting to 15. 10 miles viz, clear. 16 temperature and -2 for the dew point. 30.37 inches of mercury. Sea level pressure, and here's the actual temperatures. Williamsport, winds 160 at 10, gusting to 18, varying between 130 and 210. 10 miles visibility, clear, blah, 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 etc., etc. Here we got Mount Pocono, automatically generated 120 at 11, gusting 18. And Sealands Grove, 180 at 10, gusting 19. So that's a METAR. So there are quite a few airports that have METARs. November 313 isn't one of them. It's also not true that you have a METAR from November 79, Northumberland County, or November 8, which is for Danville. There is an AWA system at the Danville helipad, which is probably pretty close to what it is at the Danville airport. So, we do have a say weather system at Bloom, which is better than nothing, but it doesn't have things like clouds and visibility, but at least it has the wind and the other stuff, and it's useful. It's better than nothing, right? Okay, so if I'm going flying, that's the first thing I'm going to check. What's the next thing I'm going to check? I'm going to check the TAFs, the Terminal Aerodrome Forecasts. So here on the same screen, I also said, give me the TAFs. So we start at the top with Philly. It says, okay, here's when it was issued on the 18th at 17:32 Zulu. And it's valid from the 18th at 1800 Zulu till the 19th at 2400 Zulu. And initially, the winds are going to be 140 at 10 knots, better than 6 miles visibility. So P6 means +6. Few clouds at 4,500, scattered at 25,000. Then, from the 19th at 0 Zulu, so that would be 8 o'clock tonight, the winds are going to diminish down to 4 knots. Visibility is still going to be good, but guess what's going to happen? Clouds are going to be broken at 3,500 tomorrow at 4 a.m. Winds are going to be 3 knots, 6 miles visibility and mist, broken 2,000. And then we're looking at broken 4,000 at 11 a.m., which is 1,500 Zulu. And then getting a little bit better later. If I look at Lancaster, issued on the 18th at 17:42 Zulu. Valid from the 18th at 1800 to the 19th at 1800. Initially winds 160 at 11, gusting 17. Better than 6 miles visibility, sky clear. And then at 1823 Zulu, which would be 7 p.m., winds should be 5 knots. better than 6 miles visibility, and scattered 2,000. So why is it going to get better? Well, the sun sets at 6 something, let's see, 6:19 p.m. today. So as the sun sets, these winds tend to die down a little bit. Usually, sometimes they don't if there's a frontal activity and things like that. Okay, and then from tomorrow at 5 a.m., 4 miles visibility and drizzle, light drizzle, and mist. BR is mist. You can remember it. It's baby rain. In the vicinity, you should expect some fog. Broken at 1,000 feet. And then at 7 a.m., 1 mile visibility in light drizzle. Same thing, baby rain, also known as mist. Vicinity to the fog, overcast at 700 feet. So it's not looking like a great day to fly to Lancaster in the morning. Binghamton, here's when theirs was issued. Initially, they're saying winds are going to be 180 at 14, gusting to 23. Better than 6 miles visibility. Broken at 20,000. So that's not bad at all, actually. And then it's going to go overcast at 10,000 and then broken at 5,000, broken 2,300, and it's going down from there. They're forecasting light rain about 10 o'clock tomorrow morning. And by noon, light rain and overcast at 900 feet. What about Avoca? So Avoca is saying that initially they're going to have some gusty winds. No surprise there. Then the winds are going to die down. Broken 10,000. And then tomorrow morning, about 8 a.m., looking at broken 2,800. And then within 2 hours at around 10 a.m., broken 1,500. If I look at Williamsport, you'll see gusty winds. Winds go down as it gets to be evening. And then in the morning, guess what? Low visibility, fog in the vicinity, broken 1,000 feet. So you can already see, here's one of the challenges living somewhere like Bloomsburg. You can't really just average these two forecasts sometimes because, they're saying rain and they're saying no rain. So what's the average of that? I don't know. Some rain? Sometimes they'll be saying, hey, clear skies, and the other place they'll say overcast at 600 feet. So it's hard to say what you're actually going to get. Just for grins, let me pull up something far, far away like Atlanta. So Atlanta right now, it's 8 knot winds, 10 miles visibility, some scattered clouds that are a little bit low. But for them, it looks like tomorrow is going to be a lot nicer than here. And here is McCullum Field. It's also down by Atlanta. Used to have a school there. Winds are 8 knots there right now, and their forecast is very similar. So those are METARs and TAFs. Those are the big go-tos when you are looking at going to do any kind of flying. Now, of course, if you're going to go on a trip, now there's some other things that you might want to concern yourself with, such as the winds aloft. Earlier today, took a little mini trip just from Bloom to Sealands Grove. Took a while to get there. It took a while to get back to because the winds were kind of perpendicular to our course, but very strong. So if I go back to my home here, I can look at forecasts and I can say, well, I want to look at winds and temperatures. And once again, it's going to bring up this kind of graphical version. And I've got a couple of these little flags here. And I can select my altitude. I can say, well, what's the altitude that I want to know the wind's at? So this is 9,000 feet, 6,000 feet, 3,000 feet. So this is one way to tell what the winds are going to do. Personally, if I'm trying to plan a trip, this is a little bit difficult. So you can see here that the winds are out of the south. So if you wanted to go south today, it's going to take you a while to get there, but your time coming back is going to be pretty awesome. I actually had a couple that flew in to Bloomsburg today, and they were trying to go to Wellsboro from down here in Bucks County, but they said the winds were 27 knots up there, so they just went to Bloomsburg and landed, got a little bit of fuel, and flew home. They were very proud of the fact that they were doing like 144 knots at 65% power in their Archer. But I don't even want to know what their ground speed was going back, because I'm sure it was probably something more like 100 and I don't know 10 knots would be my guess, given the way the wind's blowing right now. So you can do that. The other thing that you can do, they have this little plot that kind of shows surface winds and how they're going to vary. Actually, I'm just going to click on this just to re-emphasize some stuff that we talked about last time. So you can see how these winds, you've got a high and then you got lows. So it's kind of flying from high to low, but it's also bending a little bit. And it's spinning a little bit around the isobars, but these are surface winds, so not as much as you would think. Okay, so I'll go back here. Here's what I like to use for flight planning in particular. I'll just kind of click on this region, and this is the text version of the winds and temperatures aloft. This is something you'll also have to know for your knowledge test. So if I look here, I can find Avoca. It's right here on this line. So at 3,000 MSL, the winds are supposed to be 170 at 21 knots. At 6,000 MSL, they're supposed to be 200 at 27 knots, and the temperature should be plus 0.2. There's no temperatures down close to the ground, and in fact, you'll notice that this wind is missing because it's too close to the ground. So if 3,000 MSL is too close to the ground, they just omit that number. So the winds are going to be at 28 knots at 9,000, 40 knots here at 12,000, 44, 51, 61, 66, and 78. You'll also notice it says temperatures negative above 24,000 feet, so they don't put in the minus sign because they're always negative up there. You might say, why don't they just do it? You have to remember that a long time ago, they had this stuff coming across to teletype, and it's like, tit, 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 tit. It takes forever. So they're trying to just save every little character that they could. So they would do things like that. They would eliminate a minus sign if it was unnecessary. We have winds at JFK. So that's another one of those things too, where you're like, is there a place where the wind is forecast close to you? Maybe, maybe not. We're lucky that Avoca's pretty close. So if I'm going to take a trip, if it's a long trip, the winds are going to shift. But if you look at shifting winds, let's look at Avoca again. You'll notice it starts out at 170, then it goes to 200, then 210, then 220, then 230, then 230 again, and still 230, still 230, still 230. So remember what we said. We said from high to low near the ground, and then as you go up, and that wind friction against the ground is less and less, it's going to start flying so that it's running along the isobars. So that's pretty cool. You can see that as well. Okay, some other weather products. If I stick with forecast here for a second, I can look at my convection forecasts. So I can look at convective sigmets. So those are going to tell me about convection. Sounds kind of like thunderstorms. So there's no convective sigmets around in this area. Looks like there's a little something down in Florida. I can also look at sigmets for turbulence, icing, IFR conditions, and mountain obscuration. So a sigmet is a significant meteorological event. And I don't have any of that. I can look at, icing and all that. We'll come back to that. Prognostic charts. I can say, what's the weather going to be like? And I can look at my low-level surface to 24,000 charts. I can look at my surface plots. So let me start with a surface plot. Here you can see my fronts. The blue fronts are cold fronts, and they have the pointy parts. So if it wasn't color-coded, and guess what? For some of the stuff on your test, they're going to give you those black and white charts that the only place you ever see those anymore is on the test. Everywhere else, it's going to be color-coded like this. So the biting cold is the blue ones with these sharp little half diamonds. And this is a warm front here. So you have low pressure here, high pressure here. These lines are isobars, constant pressure lines. So the tighter these are to each other, like up here, the more you should expect things like wind, right? Because the pressure gradient is stronger, if you will. So I would expect higher winds up that way. Here we have one of those stationary fronts, and there's a little key down here as well. And it says, all right, these two fronts are pretty much stalemated, if you will. And we have highs and lows, hurricanes, don't see any of those right now, troughs, a low pressure area. And it'll tell me what kinds of weather I've got going on. So that's my surface chart. I can step through time here. So I can look at my forecast. So this is going into tomorrow. And you'll notice as the day goes on, we've got rain becoming more likely. in our area. And these poor guys over here are getting snow and mixed precipitation. So that's my surface chart. Let me go back to my Prague charts. If I look at my low level surface to 24,000 feet, if I go ahead and click on this, it'll show me, all right, here's my low level chart. And if I look at these panes, you'll see that this one says valid time 00 Zulu, and this one is 12 Zulu. And it's interesting that these are so small. I could zoom in with my browser, but I don't want to because then it's going to cause other weirdness. But anyway, there's a key. So the red will show you areas of IFR. The blue scalloping will show you marginal VFR. So, here you can see IFR here and marginal VFR around it. And then I can see moderate or greater turbulence, and then freezing levels. And guess what? Once again, I can step through. I guess I could click on enlarge map. There we go. And I can step through and say, all right, this is valid at 100 on the 19th. And if I step forward, doesn't seem to work very well. Okay. Oh, it's because of the way this thing works. All right, so it's not wanting to step forward for me. I can also get the black and white charts, which again, this is what you're going to get on your test. You're not going to get the nice color charts. And that's going to give me a general idea. So why would I use this? I'm taking a longer trip. Maybe I want to go to Michigan. So I need to know what the weather is over a larger area. Now, speaking of weather over a larger area, I believe Rod talks about things called area forecasts. Now, area forecasts have pretty much gone away, with the exception of Alaska. So let me go back here. And if I go to forecasts and I say area forecast, it's going to say, hello. What's an area forecast? It says, hey, the text area forecast for the contiguous United States has been discontinued. Instead, use the GFA tool, the Graphical Forecast Area tool. All right. Well, I can click on this link. It's also under Tools. I won't go there just yet. So, what are some other forecasts I can get? I can get, again, turbulence and things like that. And I can say, all right, I want to look at reports from aircraft and, whatever, airmets, sigmets, things like that. Advisories, sigmets, and airmets. So what's an airmet? An airmet is like a sigmet, but it has a much lower threshold. So here you can see the blue, and here we've got this blue shading, and you can look at this guy here. And it's saying that, that's icing. You got turbulence. There is a little thing here too. It says turb. So what is this? And again, you can step through the different times and you can make it bigger if you need to. Okay, so let's go to tools. Flight path tool. You can basically say, where am I going to be? You know, what's the weather along my flight path? And I have to use Java for this. I'm not going to use it because I don't actually have Java installed in this computer. GFA tool. I can say, what do you want to know? What do you want to see? And I can say, all right, I want to see TAFs, ceilings, visibility, clouds, precipitation, thunderstorms, winds, turbulence, icing, and then I can go through my different flight levels and I can change my times, right? So I can kind of drag this little slider forward and I can see different forecasts. So it's a nice little tool. I can submit PyReps from here. I don't know how I'd be doing that from a computer. You know, probably should be flying when that happens, but it is possible. Now, one thing I almost forgot to do. Observations. So we got METARs, aircraft reports, and we also have radar and satellites. So radar, you have the option of seeing the national weather radar, or you can look at a single site. So I can click over here on OCX, and now I can see composite reflectivity. You know, I can see base reflectivity. You know, I can do whatever I want in terms of the radar. I can say, please loop it. By the way, you'll see how there's this trash here. That is what we call ground clutter. It doesn't really mean anything. So if I move one direction or another to the next single site, so I move over here, and now that ground clutter is going to go away, right? And I'm going to have new ground clutter here as opposed to where I had it before. So here we are at State College. And you can see the coverage. It's got a little oval that shows you what the coverage is for that. All right, so that is pretty much what you need to know about using weather from online sources. Now, if you have things like ADS-B in your aircraft, you can receive METARs. You can receive radar even. Now, you can also receive these things if you had, for example, a in-flight internet connection, like maybe you have a tablet and you have cellular data. You can also get that way. There is satellite weather that you can also subscribe to, but that costs money. And ADS-B in is free other than buying the equipment. So a lot of people tend to use that instead. You know, for example, I'll use my Stratux, which is an open source product, and you can build your own or you can buy one pre-built for less than $200. And that's got ADS-B in on both channels, and it has a GPS, and it has an AHAR system to give you attitude information in a pinch. So if your gyros go for Anya, you can use that. Okay, so that is pretty much chapter 13 about different weather products.